Hi, today I'm going to talk about how to solve first-order linear differential equations using an integrating factor. This method should be used when the differential equation is in the form of dy by dx plus p of x y equals q of x. Now, we use something called an integrating factor, which we take to be e to the integral of p of x dx, and here we disregard any constants that we find in the integration. We use this because of an interesting fact that when you have a function e to the integral of p of x dx, also known as the integrating factor, multiplied by y, and differentiate it using the product rule, we find the answer to be e to the integral p of x dx dy by dx plus e to the integral of p of x dx multiplied by p of x dy. Sorry, not dy, just y. And this is useful because if you divided all of this entire equation by e to the integral of p of x dx, then you get dy by dx plus p of xy, which is the form we see over here. And that's why our integrating factor is so important. It means that if we had this equal to that, then multiplying all of this whole equation by what I'm going to call if now, we would get I dot f dy by dx plus I dot f p of xy equals I dot f q of x. And we know that this is the same as this, which means these two can be equated. So if I do that, I'm going to find that d by dx of, and I'm just going to write if now, of I dot f multiplied by y equals I dot f multiplied by q of x. And now I'm going to do some basic rearrangement to find what y is. So first, the opposite of a differentiation is integration. So I'm going to say I dot f times y equals the integral of I dot f multiplied by qx dx. Then I'm just going to say y is equal to 1 over if multiplied by the integral of if times q of x dx. And here we've derived an equation for y using our integrating factor. Now, substituting the integrating factor back in, we find that y is equal to e to the minus integral of p of x dx. We do minus because it's 1 over, multiplied by the integral of e to the integral of p of x dx qx dx. Now, this looks a lot more complicated than it actually is. But, so what I'm going to do to help that is I'm going to show you an example. So let's say we are given a differential equation of cos of x dy by dx plus y sine x equals 1. Looking at our original form, which we wanted to compare to, dy by dx plus p of x y equals q of x. Sorry for the shouting outside, there's a bunch of crazy kids out there. We see that this is almost the form we want it in, but there's a cos over here. So what we're going to do is just divide all this entire equation through by cos, and we get it dy by dx plus sine of x divided by cos of x just becomes tan of x. So it's just tan of x y, and 1 over cos x is sec x. And then equating between these two, we find that p of x is equal to tan of x, and q of x is equal to sec of x. And now, if we want to find y, all we have to do is substitute these into this equation here and solve. So now we're going to do that. I'm going to say, or actually, I'm going to write it as an integrating factor to make it a bit more easier to understand. So I'm just going to say if equals e to the integral of tan x dx. And remember, we ignore any constants. So the integral of tan x, well, tan is sine over cos, and cos and sine are derivatives of one another. So when you have a fraction like that, you find that it's equal to e to minus ln of cos x, like that. But if we look at the power rule of logs, sorry, not the power, was it a power? Yeah, it's power. We just take this over here, and we get e to the ln of 1 over cos x. But look, you have e to the ln, and they cancel out, which means that our integrating factor is really just 1 over cos x, which is sec x. So now we have y equals e to the minus that, or in other words, 1 over the integrating factor. 1 over the integrating factor is just cos x. And then multiply that by the integral of the integrating factor, which is sec x, multiplied by q of x, which is also sec x, dx. So then y is equal to cos x multiplied by the integral of sec squared x dx. And the integral of sec squared dx, which is a standard integral you should know, is tan of x. So y equals cos of x multiplied by tan of x. And here, obviously, don't forget the constant. I'm going to say plus a. So it's cos of x multiplied by tan of x plus a, which will give me a general solution of sine x plus a cos x to the differential equation. And that was a derivation of the equation to solve first order differential equations using the integrating factor, and an example of how to do it.